The idea that the planet could one day begin to cool if emissions are reduced has long given the world a fragile sense of hope. Yet recent discoveries about the vast reservoirs of heat stored within the oceans are now challenging that assumption. The seas have quietly absorbed more than 90% of the excess warmth generated by human activity, acting as Earth's hidden thermostat. But this storage is not permanent. The energy trapped in deep waters does not vanish. It waits, it circulates, and eventually it resurfaces. As scientists reassess global climate budgets, they are realizing that the ocean's role has been misunderstood. It has delayed, not prevented, the full force of global warming. The implications for human health and for hospitals planning to cope with environmental extremes are deeply unsettling. What we thought of as a temporary pause in temperature rise may in fact be the calm before an era of unprecedented heat stress, disease outbreaks, and medical system overload. When policymakers calculate safe emission targets or project temperature stabilization, they often rely on models that assume a relatively linear relationship between atmospheric carbon and warming. But oceanic heat storage introduces a dangerous lag in this relationship. The warmth already absorbed by the seas can return to the atmosphere decades later, even if human emissions stop tomorrow. This means that future generations are locked into waves of delayed heating, creating a form of climate debt that must eventually be repaid in rising temperatures. This debt translates directly into human suffering. As ocean heat is released, it amplifies extreme weather, longer heat waves, warmer nights, and intensified humidity. These conditions are especially deadly because they prevent the body from cooling and stress the heart, lungs, and kidneys simultaneously. For health systems already stretched thin by population growth and infectious disease, this is a slow-motion catastrophe in the making. Hospitals and public health planners have built much of their infrastructure under outdated climate assumptions. Cooling systems, emergency response capacities, and even building materials were designed for a world several degrees cooler than the one emerging now. When heat extremes push beyond these design limits, healthcare facilities become part of the problem rather than the solution. Power failures during heat waves can shut down life support machines, compromise vaccine storage, and force emergency departments into chaos. In poorer regions, where electricity and water are unreliable, a single prolonged heat wave can lead to cascading hospital shutdowns and mass casualties. The stored heat in the oceans makes these scenarios not only possible but inevitable, as intensity and frequency of extreme heat events accelerate beyond historic precedent. Moreover, ocean heat affects disease dynamics in subtle but devastating ways. Warmer seas mean warmer air, alter rainfall patterns, and expanding habitats for vectors like mosquitoes and ticks. Diseases once confined to tropical regions, malaria, dengue, chikungunya, are now appearing in temperate zones, forcing public health agencies to contend with pathogens they have no experience managing. Hospitals in Europe, North America, and East Asia may soon face outbreaks of diseases for which they have limited diagnostic tools or treatment protocols. The persistence of oceanic heat ensures that these patterns will not reverse quickly. Even if emissions decline, ecosystems and disease vectors will take decades to stabilize. This lag between environmental change and biological adaptation creates a permanent sense of medical uncertainty. In addition to infectious threats, ocean-driven heat release worsens air pollution and dehydration-related illness. As sea temperatures rise, more water evaporates into the atmosphere, fueling stagnant, humid air that traps pollutants over urban centers. The result is a toxic combination of heat stress and smog, conditions that drive surges in asthma, heart attacks, and premature deaths. Hospitals must prepare not just for more patients, but for entirely new categories of climate-linked syndromes: chronic heat injury, acute renal failure from dehydration, and compounded respiratory distress from polluted air. These are not distant possibilities. They're already being recorded in cities from Delhi to Phoenix, from Athens to Shanghai. Public health planning must therefore shift from crisis response to climate adaptation. Traditional approaches, stockpiling medications, building more clinics, or adding cooling centers, will not be enough. Health systems must anticipate chronic, compounding stressors that evolve with every year of continued ocean warming. This means rethinking the very structure of medical care, where hospitals are built, how they are cooled, how they store energy, and how they communicate during environmental emergencies. Medical education must also evolve, teaching future doctors to recognize and treat the physiological effects of extreme heat and climate-related diseases. The notion of climate literacy is no longer optional for the health sector. It is a survival skill. But the warning extends beyond hospitals. Oceanic heat storage challenges the comforting belief that emissions reductions alone will quickly translate into safer temperatures. Even in a best-case scenario where fossil fuel use declines sharply, humanity may still face decades of delayed warming from heat already trapped below the ocean's surface. That means public health systems must prepare not for stabilization, but for escalation. The heat we have already set in motion will continue to emerge, reshaping disease landscapes, food supply, and water security. The moral and scientific imperative now is to confront this delayed danger honestly and to plan as though the world is already living through the early stages of it, because it is. There is a growing sense of urgency among climate scientists that we have underestimated how much future heat is hidden beneath the waves. For every fraction of a degree that the ocean conceals today, millions of people could face deadly conditions tomorrow. Hospitals, as the last line of defense, are being forced into the role of climate responders rather than mere health providers. The question is no longer if the stored ocean heat will return to the surface. It will, but whether our public health systems will be ready when it does. Without rapid, coordinated investment in climate-resilient healthcare and infrastructure, the release of that oceanic heat could trigger not just environmental instability, but a global health crisis unlike anything in recorded history.